say namespaces, even though that's a slightly overloaded word. But Objective-C is perfectly okay with you having methods that have the same name as your variables. It treats them differently, so it doesn't have to worry about them complaining against each other. Some other simple methods is perhaps being able to set the numerator and denominator. So, what is this method signature? What is this method going to look like, do you think? Maybe have a guess? Okay. So let's say set numerator, colon, int, and I'm going to call it numer, just so that it's different than the instance variable, because that name will collide if I name it the same. Okay, and set denominator will be the same thing. Oh yeah, just to make the name. Thank you. And how about reduce? It's sometimes it's useful to be able to reduce a fraction to lowest terms. That really all we're going to have that modify the object, so that way it's now in lowest terms. Okay. So, is this clear? Is everybody okay with how I define the header for this class? Okay. So now let's go in and actually define these methods. I'll talk about init a little bit later. For now, just that's where the object is going to get constructed. Don't worry about that. We'll just, in fact, I can actually delete it and just use the superclass method because I'm not going to do anything with it. Okay, so the way you define a method is you basically copy paste the signature of the method, and then within curly braces is where you put the code. So these methods should be really trivial, guys. We're just going to return numerator. And similarly, we're not going to autocomplete. Oh, why are you not auto-completing? No. Okay, so here we're passed in a numerator, and we want this to be set as our numerator. So we're just going to assign the value numer to numerator. And notice we don't need to say self dot or this dot. It knows that that's our instance variable and can keep track of it. If Xcode was behaving, it would actually syntax highlight that and make it green to indicate that it's an instance variable. Xcode 4 is almost perfect. It still has a few flaws. One of them is it has trouble with syntax highlighting sometimes. The static analyzer is a little bit weird sometimes. Okay, and then similarly set denominator. Again, not super interesting. Reduce, and I'm going to kind of cheat here. So the way you reduce a fraction, for those of you who remember, is you find the greatest common divisor of the numerator and denominator, and then just divide both of those by that value. So I'm going to pretend I've defined a C function called GCD. And I'm just going to give it the numerator and denominator. And that should just, I'll pretend that gives me, I had it once, but
You don't have to give a name.
Oh, I should name that variable, huh? Let's call it GCD. And now all we're going to do is we're going to take the numerator and denominator and just divide it by the GCD. So our new numerator is going to be the old numerator divided, I can use divide equals. Divide equals GCD. But I could also have written this like this. Same thing. And I don't need to return anything, I just want to modify my own local state so that I'm now in lowest terms. Okay. So hopefully that gives you guys a flavor of how we're going to define, how you define an Objective-C class. So are there any questions about that demo? Hopefully that was pretty straightforward. The methods I wrote weren't very interesting. And as I'll talk about on Thursday, you actually don't really have to write those. Okay, so I'm going to skip these slides because this is just me doing it by hand. I left these up here for reference. I might have put GCD in here. No, I didn't. Okay. Oh, I guess that's the other thing I could have done. I could have checked that the denominator is not 0 because you don't want to divide by 0. But again, I should have colored it if it came. Anyway, I'll leave that up for you guys to look at. So variables in Objective-C are declared just like in C. I don't really know what more to say about that. They're declared just like C. They need to be declared before they're used, but they can be declared. They can be defined and declared on the same line, just like with C99. Like I mentioned earlier, objects are always pointers. The reason for this is that they live on the stack, so we need a pointer to where. Or sorry, they live on the heap, so we need a pointer to where they live on the heap. And they're just like I said, they're actually just a structure. That has some special stuff that the runtime system knows how to query information about. But it's always declared as a pointer type. So just keep that in mind as you're declaring variables of objects. They need to be pointers. Objective-C allows you to mix and match C strings, which just have quotes around them, and NS strings. So this is how you declare a literal string object. They can contain Unicode text. The key point is that this is an object that you can send messages to. This is not. That's just a literal character array. Under the hood, an NS string is a character array with some stuff added to it, but you cannot message a C string, but you can message an NS string. Does that make sense? Okay, so like I mentioned earlier, Objective-C types usually are statically typed. So my dog my dog Fido, we statically type this variable called Fido to an object of type my dog, but we can also dynamically type them to id, which is basically void star for those of you who are familiar with C. It's basically any pointer type, so you can potentially shoot yourself in the foot with this. The main reason this is useful is if you have, for example, an array of objects and you don't know what type all of them are, you can just declare, and you want to loop through them, and you just want to pull them out one by one. You can just declare a temporary variable of type id that's, I promise this is some object. And then you don't really care, maybe you don't care what kind of object it is, as long as it's an object that responds to some message. You can just call it id. In general, it keeps you more sane if you statically type as much as you can, because then the compiler will be able to tell you if you're doing something dumb. And again, like I mentioned earlier, method binding is done entirely dynamically and entirely at runtime. So that's kind of why we can get away with having this dynamic type, is that it doesn't need, Objective-C almost doesn't need to know what exactly type it is, because it'll just figure out what it is based on the runtime. But it's helpful for us to make sure that we're coding things sanely. So one pretty cool thing I think about Objective-C is the ability to, at runtime, learn about some object that maybe you don't remember how you created it or what even kind of object it is. So Objective-C allows you to determine the type, grab information from an object completely dynamically at runtime. So you can always ask an object for its type. I think I have a couple of methods on the next slide for how to query this information, so hopefully I did those. Okay, so every object that inherits from NS object responds to these methods. Is kind of class, which returns true if the object is some kind of this class or one of its descendants. Is member of class is slightly more specific, and then it excludes descendant. It's only if it's of this exact type. Generally, these are not necessary, and if you find yourself using these a lot, you're probably doing it wrong. But they're there for you in times where you do need them. Another really handy method, and we won't really talk about what selectors are until next time, I think. But there's this method called response to selector, which allows you to basically pass in the name of a method, and it will tell you if that object actually responds to that. That is, if you give it that message, would it do something? Would it not crash? Which is really useful when you're working with objects of heterogeneous types and you're not quite sure if it listens to this method and you don't want to crash if you call it. So you can just wrap it in an if check to see if it responds to this method you're interested in. So those are pretty useful.
Question.
Yeah.
Is there a way to get it to return a list of all the methods that it responds to? Like Python?
I believe Objective-C runtime has a way to do that.
Yeah.
In general, you don't need to do that.
Yeah, you really, unless you're writing some low-level utility or some debugging utility, you're probably structuring things incorrectly if you have to actually find out ahead of time everything that an object, all the messages that an object responds to.
But sometimes when that's useful is if you think you want to like learn about how the underlying system code works, and you want to capture every time this one method is called, it's defined on some class you haven't defined, you can actually just redefine your own method and get notified when it gets called. It's really kind of hacky and swizzly, and you usually don't need to do it. But you can, which is pretty cool, to be able to just modify objects completely at runtime. Which is how a lot of developers get past not being able to use private APIs. They'll try to cover it up by doing clever things like that. Don't do that. Okay, so Objective-C has a function called NSLog that's pretty much an exact analog to C's printf. The main difference is that the first parameter is an Objective-C string, not an NS string. And unlike printf, it automatically appends a new line. In addition, before your string, it also appends the timestamp and the thread number, I believe.
You said it's not an NS string?
It's not a C string.
Not a C string.
It is an NS string.
Yes, the first parameter is an NS string.
This is a really, really, really helpful
so if you're a printf debugger, this is your friend.
Yeah.
I know I sort of
use these copiously when you're first starting out.
Okay, and like I said, it works exactly like printf. Objective-C introduces a new object and a new format specifier, which is %@, which allows you to is the format specifier for an object. So you can, if I had some object, I can say NSLog this, comma, my object, and it will print out whatever the description of that object is. And there's a method defined on NS object called description that's roughly the equivalent of Java's toString. That will just print out the string representation of this object, which you can override in a custom class. Otherwise, you look at some funky looking thing in angle braces that we do in readdress. Some mostly unuseful information. Okay, so here's some examples using NSLog. Here's how you say hello world. You put that in a main function, and that's your hello world program. So here's an example if we want to log the value of a fraction. We can create a format specifier that gives us %d, which is the format specifier for an integer, divide %d, and grab out the numerator and denominator. The new compiler will actually be smart enough to be able to tell if the number of objects you passed in doesn't match the number of format specifiers that you have, which is pretty nice. It didn't used to be able to do that.
It can even check the format specifier bit widths too, which is also really nice.
And here's an example of logging out an object. So we have some array, and we want to log it out to the console. We can log it out with %add. Yeah?
What is the %add sign?
What is it?
%add sign?
Yeah, it takes in any subclass of NS object.
It's a format specifier like %d, %u, %l, %f, but it's specific to Objective-C, to NSLog, and it takes an object and calls description on it and prints the description out. And a lot of the ABL types will spit out a ton of information. So you can override description and provide your own description, but using this on, say, this array, and if your array was full of a couple of objects, it'll list out, like in Python, it'll list out all of the objects that are contained within that array.
Yeah.
So when you create your own classes and you define a description method.
Yeah, so if you define your own class, you define a description method, then you can log it out using %add. If you don't, then you look at some funky weird thing that the memory address is.
So in this instance, you could override in the fraction class, you could have overridden description and had that return back the string, the NS string of the numerator / denominator, and then here you would just say frac equals %at and then pass just your fraction in, and it'll call your description.
Which is arguably the better way to do it.
Yeah.
But I just to have a pedantic example, I wanted to show you that you can still use all the old C format specifiers that you know and love, and have the fixed width and the number